Hi guys, welcome back to Sample Survey Methods. In this two coming weeks, we will move on to Chapter 4 in Stratified Random Sampling. So previously, we discussed about the simple random sampling scheme. In simple random sampling, we just assume the sample units, they are randomly distributed within the population. Then we select the sample unit randomly from the population to form our sample. And then within the sample, we do our calculation, like estimating the mean, the proportion, and the total for the population. If we have additional information within the sample, like we know that xi, yi, they are linearly correlated, then we can even apply ratio estimation and regression estimation. Okay, so make sure that you are quite clear about how we perform all these steps or the technique in simple random sampling, because we are going to make use of those techniques to move on to and then to apply to stratified random sampling. All right, so a stratified random sample is obtained by dividing the population's elements into non-overlapping groups. They are called strata. And then we select random sample directly and independently from each of the stratum. So what that means, for example, we want to estimate the average income for Hong Kong people. Then we can easily divide Hong Kong into 19 districts. So we call them 19 strata. And then within each stratum, within each district, we randomly select some samples or randomly select some of the personnel to ask about their income level. And then we calculate the estimate for each of the districts. Then collectively, we aggregate them and to estimate the entire Hong Kong. And this stratified random sampling, we need to pay attention that each of the stratum, they are non-overlapping. And within the stratum, we select the sample directly and independently. Okay, so you can imagine like within each of the stratum, we perform each of this chapter 3 that we learned about, and then we aggregate them to the entire population. Then you may ask, what is the advantage of stratified random sampling? Why not we simply do simple random sampling? First of all, if we are interested in some of the subpopulation estimate, like we are in particular interested in a particular districts of the average income, then we can also report about that. So not only for the entire or the whole population, we are also interested in some of the subpopulation, then we can perform the estimate for each of the stratum. Administrative convenience, and this is more related to the cost and the timing or the budget, etc. We can ask each of the district council to perform the survey and then collect data from them. This is easily conducted. Different sampling fractions and methods may be required for different parts of the populations, treated as different strata. So within each of the stratum, we might have a different fractions of sample to be collected and different methods. And then after all, we can collectively do the aggregations for the entire populations. Stratification, most importantly, stratification may produce more efficient estimate for the population. This is the most important part. Let me try to underline it. They are becoming more efficient with the estimates. So that means we are likely to having a smaller estimated variance for our sample mean. If the population is heterogeneous population and divide into strata, they are internally homogeneous. If this is the case, stratification would be most efficient. What does that mean by population is heterogeneous and the strata is internally homogeneous? Heterogeneous, that means they're quite different. So within the population, we know they are not very similar to each other, some of the characteristics. But within the stratum, they are homogeneous, they are similar to each other. So I always use an example like the estimating the average income. So like in Hong Kong, we know that there are 19 or 18 districts. Then within the districts, the average income or the living affordability would be similar within the district. So let's say people living in Wan Chai, they are about with this more similar affordability for the living, and then they are homogeneous internally. But comparing different strata, so in a different district, let's say somewhere in the south, Hong Kong South, they are relatively at a different income level. So between districts, they are heterogeneous, but within districts, the average income level are very similar. So if we are going to do that, we stratify Hong Kong into 19 strata. Stratification would be a better sampling scheme. As opposed to stratification that we talk about, that like cluster sampling. For cluster sampling, we want it within the cluster, we want heterogeneous. We want them to be quite different. But between clusters, we want them to be quite similar. So it depends on what kind of variable we are interested to estimate. Then we would apply a different sampling scheme. So back to stratified random sampling. If we find that the population itself is quite heterogeneous, but we can easily divide the population into different strata. Within the stratum, they are quite similar. They are homogeneous. So stratification will result in a more efficient estimate. In other words, the variance would be smaller. Some of the example for stratification is, for example, like household surveys is often stratified by locations, like districts. We just make use of this example, or some of the urban area, rural area. We can easily divide the population into those strata. Another example, we want to do a business surveys, then we can again easily divide the business into either they are public or the private sector, big firms, small firms, big market cap, smaller market cap, medium market caps. So we can easily divide the population into different strata. And then we know that between strata, they are quite different. Within the stratum, it is very similar. So we would prefer to do a stratified random sampling. Okay, so before we move on to the estimation, I like to talk about the notation under stratified random sampling. So in the population, we divide the population into strata. Okay, so if I can try to draw. Oops. No. Good. Okay, let's move on. Keep going with these. Okay, so let's say if we have a population like Hong Kong, we divide Hong Kong into 19 districts or 19 strata. So number of strata, capital L, represent how many strata we want to divide the population into. And the indices of the strata, little L, will go from 1, 2, 3, all the way up to the total number of strata. Size of stratum, so within each of the districts, we have the population size, right? So we have a capital N, L, to indicate this is a particular district's population size, and the sample size of the stratum. Within the stratum, we would perform a simple random sampling. So we need to decide the sample size from the stratum. So little nl would indicate that particular stratum that we collect a certain number of samples. If I add up the total population size of each of the stratum, like District Wan Chai, District Central, the South, Sham Shui Po, etc., and then we would have N1, N2, all up to N19. Then we have the total population size in Hong Kong. Total sample size to N. Again, that would be the summation of each of the stratum sample sizes. Weight of stratum. So this is very important. We have a capital W to indicate the weight of each of these districts. So the weighting would be weighted by the population size. Okay. So for example, the population size, the populations of Wan Chai out of the entire population in Hong Kong would be the Wan Chai weighting. Of course, we can weight it by our sample size. So our Wan Chai sample size out of the total sample size would be indicated as the lowercase WL. Okay. The Y value of the ith unit in stratum L. So in a particular district, we collect the value. So a particular person from Wan Chai, so that person would be Y Wan Chai, the fourth person, etc. Okay, so those are the values collected, like the income level. Sample taken from stratum L, so that's indicate the entire sample space in Wan Chai, so including this guy and some other guys from Wan Chai. Population mean, so within we can treat each of the stratum like a simple random sample, right? So within the stratum, we can estimate the mean value. So mil L indicate the population mean from the stratum L. Sample mean, of course, we have the true population mean for Wan Chai estimated from our sample for Wan Chai. Okay, so Y bar L, that would be the unbiased estimator for the population mean for a particular stratum. Again, population variance of the stratum would be sigma L square. Okay. For some of the reason, we also have the estimate capital SL square. This would be the estimate for the true variance as sigma L square. Okay. This is a true value for the particular stratum. If we cannot have the true value for the stratum, we can only estimate from our sample variance. So we have a lowercase SL square for the estimated variance. How to draw a stratified random sample? Very typical. Stratified random sample is usually drawn in 2 steps. The first step is clearly to specify the strata. Like from Hong Kong, we can easily cut it into different strata, non-overlapping strata. We place each sampling unit of the population into the appropriate stratum. After sampling units are divided into strata, within the strata, we select a simple random sample from each of the stratum and then do the calculations. All right. So specifying the strata may be more difficult than it sounds, but it is essential to specify what is meant by each of the stratum, so we can clearly divide them into different stratum, non-overlapping. We must be certain that the samples selected from the strata are independent. So each of the stratum are selected independently, randomly within the stratum. So it is like performing a simple random sampling within the stratum. Different random sampling schemes should be used within each stratum so that the observation chosen in one stratum do not depend upon those chosen in another. So each of the stratum, they are independent. Of course, within the stratum, we select our sample independently. Okay. We stop here.